So it is definitely not the silver bullet. The other thing also, we bring the inoculum right after treatment with streptomycin. And in your orchard, you might bring streptomycin today, inoculum might come in 2 weeks' time, and the effect of streptomycin, of course, would have been not as good as what we have here in those experiments. The other thing I want to talk about in that graph, what about those products here? What are we saying about those products? Clearly, in our experiment, they didn't give much control, didn't give any control at all. Are we saying we discard them and we don't look at them? No. What we're saying is that we have an assay here which is a very tough assay. We have a high level of inoculum on seedlings in conditions that are favorable for PSA to grow. It might be that this product right here, at a different dose, at a different time, or perhaps in combination with one of those products right here, it might be that one of those products would work. Or perhaps it would work if we would have a much lower inoculum. At this stage, we do not know, and later on we might revise the efficacy of those products. But what we need today, it is some products that work well under very tough circumstances with a high level of inoculum, and it is what those experiments are designed to do. Okay, something else we talked about earlier, it is elicitor. And we heard a lot about elicitor. It is also immunity enhancer. It is plant resistance mechanism. It is all those terminology that says we're not going to kill PSA, we're going to make the plant resistant to PSA. And we have here some experiments that have been done on Bruno seedlings. Again, if the seedlings were treated with water and then inoculated with the amount of disease, and here we have a number of elicitors that have been trialed. And some of them give good results, and some give results which is not as good. In actual fact, I came a while ago and I presented that product here, which is the elicitor number 3, which is in actual fact Actigard. And I said, oh, well, this product is working well on Bruno, but because it influenced the plant, we need to check that we would get the same efficacy if we were working with another cultivar of kiwi fruit. And this is what we've done. So that here is on Bruno, and now the same elicitors on Hayward. Again, your water control, if you don't protect your plant at the amount of disease you've got, and here all the elicitors, and it seems that all of them are working if you didn't protect or inoculate your plant with the amount of disease you have. And again, here it is our Actigard, and it does work quite well. This is Hayward. What about Hot 16A? Here it is. Water-treated plant and inoculated, amount of disease. Your blue elicitors, clearly, whoops. Oh. Okay, so clearly this elicitor here is not working on Hot 16A. It was working on Bruno, it was working on Hayward, it's not working on Hot 16A. Same for this one here. It's not working on Hot 16A. We have one, and again, this is our Actigard, gave us some consistent results. Those are not actually significantly different from the water-treated control. So what are we trying to say about elicitor? What I'm trying to tell you is that elicitors, they work by influencing the plant. Not all elicitors are equivalent. It's not because it is called elicitor that is going to protect your vine. We need first to check it. We have here a perfect example of an elicitor which is not protecting the vine. And we need to check on a case-by-case basis whether those elicitors actually do work on the cultivars you want to work with. Another characteristics of elicitors are the difference of antibiotics that works immediately on PSA. Elicitor needs a little bit of time. They need time because they tell the plant to produce some compound that kills PSA. And here's the illustration. We have plants that were treated with Actigard, and the same day they were inoculated. This is the amount of disease we have 1 week after inoculation, 2 weeks, and 3 weeks after inoculation. In this condition, your product has not worked. What about if you waited 7 days before inoculated? So now the plant had 7 days to get its system working to produce those antibacterial compounds. And here we have, after 1 week after inoculation, 2 weeks or 3 weeks, some effect now of our elicitor. What about if we wait 2 weeks? Here we are. And we have, again, a better result than we had immediately. And you can wait 3 weeks, and it's actually where we got our best results. So if you treat your plant 3 weeks before PSA comes in and infect, it is where those elicitors will give you the highest level of protection. This is here, this little bar there at the bottom. It is plants that were treated with the elicitors, and in red, the plants that were treated with water. Another thing about elicitors is that you can apply them in a different way. We have here the same elicitors. We brought it as a root drainage, and this is the amount of control we got. This is our water-treated plant, a lot of disease. Actually, all the leaves were dead. And here, different rate of our elicitors, and we have a good level of control. The same elicitors now brought as a foliar spray, and the same story. With our water, a lot of disease, and if we bring our elicitors, very little disease. Okay, that doesn't mean, by the way, that elicitors are systemic. The elicitor is recognized by the plant, and there's a message in the plant that travels up and down and gets the resistance in places where the plant was not treated. Now, talking about systemic, it would be great if we could have a product that moves in the plant and protect the plant from inside. So here, couple pictures, if we can do that. It is, believe me, a kiwifruit flowers. What happened? We put the cane into a suspension that contains a dye. The dye was picked up by the plant, and we can look where it is. And we can see that the plant has traveled throughout the cane and arrived through our flowers and started to accumulate on the outer edge of the petals. And if you would have leaves, we can see that the dye accumulates in the outer edge of the leaf. You see the bluish tint here. The good news is, if the dye was streptomycin and PSA would land onto that stigma here, well, not a chance to get infection. That's fully protected. Unfortunately, some of those stigma here didn't receive the same amount of product, and perhaps the stigma could still be susceptible to infection. The hope there would be that if PSA travels through one of these parts where there is no dye and no product, it would soon encounter a region where the product has been deposited, and that would kill the PSA. So can we bring now some of those products into the plant? Can we have, instead of spraying some of those products that shows efficacy, can we bring them in? And this is the second part of the talk, and it is about some experiments that were done with Shane Max from ZESPRI, from the OPC group in ZESPRI, and we looked at trunk injection. And when we look at trunk injection, because that has been done in all the crop and seems to be working, and we believe it was a worthwhile things to look at. So we tried a number of products, some because we knew they were working, some because we believed that they would have some efficacy, and some product that are proprietary from some companies. So here one of the ways of putting the product, drilling, and then forcing the product into the plant. Well, what have we done? We tried a number of different experiments, and we selected some cut stumps. The idea there, you've got a vine that is infected, you need to cut it off. You stay with a stump. Can we clean up that stump with some of the product by injecting them through the stump, and then you have a clean stump and you can start again? We looked at leaf-spotted vine. The idea there, you have a vine that you know is infected. PSA is there. If we bring something like streptomycin in it, can we have a curative effect? Can we kill PSA while PSA is in the plant? We also looked at non-leaf spotted vines. So vines where we do not see any symptoms, we believe they're not infected, but they're in infected orchards. And the idea there is, can we have a preventative effect of products that are injected into the vine? Those trials were set up in a number of plots, and we use different apparatus, stem shot and side window in particular, but also other apparatus. And the applications were done in autumn and in winter. So here are the results. So on Hot 16A, we had some Hot 16A orchard. Unfortunately, none of the product here, all the product, none of the product gave us any protection against PSA. In actual fact, in a number of those orchards, by the time we arrived and wanted to assess, the plant had to be cut because of presence of secondary symptoms. We had some experiments on G9, and there is no secondary symptom, and that seems good. Except there's no secondary symptoms in the plant that were not injected either. So it's not the injection that prevented those non-secondary symptoms. So from that experiment, we still have some that needs to be assessed, and of course we're going to keep looking at how that develops, and it could go either way, and we keep looking at that. And also some experiments on Haywards, and this is mostly spring application, so we'll have the results only later. Somehow that was a little bit disappointing. All those treatments, none of them worked, and we have to say, why didn't it work? Where did we go wrong? Is the idea worth pursuing or not? Well, there's a number of reasons why perhaps it didn't work. Did we use the right rate and the right volume? How much dilution do we do when we put a product in a vine which is full of sap? Does the product we use, do this product persist in the vine? Perhaps it didn't persist long enough, and because it was in fall and winter, we didn't get the product when PSA was coming in. And that comes to the timing of injection. When should we time those products and those injections? Some of the product, we know the dye can go right through the plant, but some of the products we tried perhaps got stuck somewhere. Perhaps they got stuck where we injected them, never moved from there, and that could explain why never got any symptoms. So clearly we have a lot of work to do if you want to go further with injection. I just want to point out to that picture here, we have so we have the site where the injection was done, and you can see those tissue here that discolored. It seems that when you bring very high pressure into your vine, you can actually have some damage inside your vine, and that's something else we need to look at, what to use for those treatments. So where to from here? There's still some trials we're looking at and we're monitoring, and we'll have still more results later. But clearly we need to refine the techniques. We need a lower pressure device. Perhaps if we have multiple injection sites, we can go with a lower pressure. Perhaps we can increase the rate of the product. And there is other projects that are going on now, in particular to understand how any product can move up and down into the vine. And of course, we had to put that little note there to remind everybody that if you want to use streptomycin injection, you can't do it without a CVM approval. And of course, all that here was done with a CVM approval. So conclusion, we have a product testing project that aims at selecting winners. We have a couple of them. And there'll be more products to look at later or revise with different bioassay. Streptomycin so far has been the most consistent product. It is not the silver bullet, but clearly it has been consistent in all the assay we've done. Elicitors, some elicitors clearly might be part of the solution. Not all elicitors are equivalent, and we need to remember that. Spraying, well, spraying might work, and it does work. And this is probably what we need to use for now, but we're also looking at whether injection in the future could help, and in particular, not at protecting the vine, but also at curing the vine from PSA. And I'll stop there. Thank you.